This video is going to be about electronic configuration and how you can write that out for a species. So our electronic configuration is the distribution of electrons in an atom, molecule, or ion in an atomic or molecular orbital. So electrons can be in s, p, d, or f orbital shells. And we've learned that s orbitals hold 2 electrons, p orbitals, or shells you might call them, hold 6 electrons. D shell is going to hold 10 electrons. And our F subshell is going to hold 14 electrons. And these are the 4 subshells we know about for all of the elements on the periodic table now. So we can use the periodic table to our advantage here because the electronic configurations can be seen easier on a periodic table. So if we look at our periodic table that I've drawn here roughly, I've left out the lanthanide series on the bottom because we're not going to deal with those today, but that's where you'd find your F subshell. We can split the periodic table into kind of sections. The first section we're going to have here is these first 2 columns, and that is our S subshell. You can see that there's 2 elements, or 2 columns here, and that's going to represent those 2 electrons. In the middle, we have our transition metals, and those are all going to represent our D subshell. And you can see there's 10 elements here, which are going to correspond to those 10 electrons. Last thing we're going to look at here on this periodic table is our P section. And you can see that there's 6 elements, or 6 columns here, that represent those 6 electrons. So let's go ahead and go through an example writing out electronic configurations, and then as you go through that you might see how our periodic table plays in. So let's go ahead and write out the electronic configuration for calcium. So calcium, if we look at our periodic table, is right here. So first we want to go through and start to write our configuration, and we always start at our top left. So this is where our hydrogen would be, and helium is here. So our hydrogen we think is like 1s1. Helium would be 1s2. So we think of that as being 1s2 because there's 2 electrons in that shell. They're both filled. If we continue to the right, we see that there's no P subshell, though, that lines up to that on the same height on the periodic table. That's because there is no P subshell in just the first energy level. So we go straight on to the second level with 2s2. Because if we go down, we see that we haven't run into calcium yet, so we keep counting through. So 2s2. Now we continue to our right, and we run into our P subshell. So we're going to have 2p6, because all 6 of our elements are here, and we still haven't run into calcium. Next, we're going to go on, and we have 3s2. You can probably start to see a pattern here. Continue to our right, we'll get 3p6. And now we're going to go down to our 4th level, and we'll have 4s2. And we're going to stop there because that last electron we look at is actually calcium. It's our second electron, shown by the S2, in that fourth energy level. So that would be how we would write our electronic configuration for calcium. Now let's do another one that's slightly more complicated. Let's look at iodine. So iodine on our periodic table is right here. So we're going to count through similarly, but we're going to stop halfway through, and we'll show you how that's going to be different. So we have our 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. But if we look now, after calcium, we have our D subshell in the middle there. And we have to take note of that and somehow write that down to show that that's there. We can't go straight over to the P's. And what we do is we end up going back in energy level, so we have 3, and that's going to be our D10. So we just simply move back energy level for a little more complicated reasons, but you just have to remember that from the 4s you go back to 3. And then we're going to move back up to our 4p6, moving on back to our 5s2. We're going to repeat this again for the 4d10. And then we can see we're going to get all the way over to our right, and we're going to have 5p5. Because if we count through, we have 1, 2, 3, 4, 5 element places, and then we hit iodine. So you always stop counting up. You could count, 5p1, 5p2, 5p3, going through these, and then when you hit the last one, that's the last superscript you put, or a little 5. So we haven't stopped yet with an element in our D subshell, so let's just do a quick example of that to kind of show how that might look. So we're going to do zinc here. So zinc, if we go through, we're going to have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d9. Or not, excuse me, not 9, 10. So it's going to be 3d10. Because you can see if we count through, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this is going to be our 10th in that D subshell. So the 3 represents what energy level we're going to be at, and the 10 represents which element, counting from left to right, we are in that line. So this is a kind of simplified way of how to use the periodic table to write out electronic configurations.